In today's video, I am going to continue solving KSET 2025 Physical Science question paper. Yes, let us start with the question. The first question says a particle of mass m is moving with the potential v of x which is equal to k into 3x minus 2 into 4x minus 1. The time period of small oscillation t about the point of equilibrium is. So the time period t which is given by 2 pi by omega. Omega is nothing but square root of k by m. If it goes upside, so time period which is equal to 2 pi square root of m divided by k is the time period. Right, now I want, instead of k I'll be writing here k effective. Okay, what does this k effective means? The k effective can be found out from the double derivative of this potential. So they have given, that's why the v of x which is equal to k into 3x minus 2 into 4x minus 1. So differentiate one time with respect to x, I'll get dv of x divided by dx which is equal to k is constant. On cross multiplying, so on multiplying this, 3 fours are 12, and differentiation of x square will be 2 times of x. Now this term to this term, 3x minus 1 is minus 3x. Differentiation of 3x is minus 3. Next, from minus 2 to 4x, so minus 2 to 4x will be minus 8x. Differentiation of minus 8x is minus 8. So differentiation of minus 2 into minus 1, it is a constant, it will be 0. So we get dvx divided by dx value to be k into 24 times of x minus 8 minus 3, it will be minus 11. Right, now I want the k effective value. This k effective is nothing but double differentiation of potential, that is d square v of x divided by d into x square. So it will be differentiate again with respect to x, k is constant, so it will be 24, and a differentiation of constant is 0. We got the k effective value to be equal to 24 times of k. So substitute in the time period formula, I get t which is equal to 2 pi square root of m divided by 24k is the right answer. So I can tick option 2 is the right answer, that is 2 pi square root of m by k. I hope the question is clear. Now let us move on to the next question. A particle of mass m is moving in a potential v of x which is equal to half of m omega square x square minus ax. What are its quantized energy levels? That is En, they have asked. So let us start with this question. They have given the v of x. I am rewriting the question here. So the v of x they have given to be half m omega square x square minus a x. Right? Yes, minus ax. Now what we need to, how we need to solve this problem is, yes, for simple harmonic motion, yes, we have the potential value to be v of x which is equal to half m omega square into x square. So we got the energy eigenvalues for this to be En. It is a standard value, it is n plus half into h cut omega. This is the formula for the simple harmonic motion. The energy eigenvalues will be n plus half h cut into omega. But what we have, instead of half m omega square x square, we have the extra term minus ax. So we need to keep v of x in terms of this x square. So what I can do, so I can do by taking common, I am rewriting again, that is v of x which is equal to half m omega square x square minus ax. Take half m omega square common, what is left inside the bracket x square minus ax. So here I took half m omega square, but half m omega square is not there in this second term. So I am going to multiply by 2 divided by m omega square. The term remains as it is. So this is the terms inside the bracket, that is x square minus 2ax divided by m omega square. From here I can write in the form of a minus b whole square. Here, what does a uh, tells you about a which is equal to x. I can found out a which is equal to x on comparing, and b which is equal to 2 times of ab. No, 2 times of a is x, b is a divided by m omega square. Why I am writing like this means I want this term in the form of a minus b whole square formula. So from here I got a which is equal to x, b which is equal to a divided by m omega square. So this equation I can rewrite it as half m omega square x minus a divided by m omega square whole square, and I need to subtract by the term that is 2 times of that is a square divided by 2 times of m omega square to keep the equation in this form only. And this equation, this whatever the inside the bracket on multiplying minus a square minus 2 omega square, we will get the above equation as it is. For the simplification purpose we have done like this. Okay, if you cross multiply and you will get the same answer, if you cross multiply this you will get the same above answer only. Now I can write this x minus a divided by m omega square to the whole square to be my x prime square is to be x prime square minus a square divided by 2 times of m omega square. Now it is in the same form like this, but we have an extra term that is minus a square divided by 2 times of m omega square, right? So I can write the energy eigenvalue to be, I'm going to write here the energy eigenvalue that is En, which is equal to n plus half h cut omega minus of a square divided by 2 times of m omega square. This will be extra term, and this is the according to the formula. We have a energy eigenvalue to be equal to n plus half h cut omega minus a square divided by 2 times of m omega square. I hope this question is clear for you people. So what are its quantized energy levels? So I can say from my solution option 2 is the right answer. Yes, let us move on to the next question. The next question is here: the magnetic field at a point due to straight current carrying conductor of radius r carrying current I, where small r is greater than r. They have given what is small r. Small r is the distance between the point and the axis of the wire is proportional to. So this question I can solve by using Ampere's circuital law. What does the law says? Yes, the law says here closed integral b vector dot dl vector, which is equal to mu naught into I. Yes, using Ampere's law, that is integral of b dot dl, that is b vector dot dl vector, which is equal to mu naught into I. For this, read out the question again, it will be clear. The magnetic field at a point due to long straight current carrying conductor of radius r. Yes, carrying current I. So how it is proportional, how I is proportional means how magnetic field is proportional I need to find, right? So now I'll see the current carrying conductor, it is in a circular in shape. So this dl vector I can write it as magnetic field b into 2 pi r, where r is the radius from point p to the current I of the conductor, right? So it will be equal to mu naught into I. Now on rearranging the terms, I'll get magnetic field b which is equal to mu naught I divided by 2 pi r, right? This was the equation and final equation we got. So I can write from here B is inversely proportional to 1 divided by R. That is, magnetic field is inversely proportional to the 1 divided by R. So they have asked you the proportionality. About the proportionality, I can see here which option is correct. Option C is the right answer. Yes, we shall tick to the option C. I hope everyone is clear. And this was the question. It is a straightforward question from the second PU NCERT book. You can cross check once. Yes. Now we will be moving on to the next question. What does the next question says? An oscillating voltage V of t, which is equal to V naught cos of omega t, is applied across a parallel plate capacitor having plate separation d. The displacement current density through the capacitor is. So they have asked you about the displacement current density. Yes, we shall solve this problem. Let us start with the problem. What they have given? They have given the V of t to be equal to V naught cos of omega into t. Right? What we need to find? We need to find the displacement current density. So what is the relation between E and, that is, electric field and the V? So electric field and the V, it is related by E, which is equal to V divided by D, where D is the distance between the parallel plate capacitor. Yes. Now, what is the formula to find the displacement current density? It is represented by the symbol JD. The formula is equal to epsilon naught dou E divided by dou T. What does this dou E divided by dou T means? It is a partial derivative of E with respect to T. Now, I'll take E of T in terms of V of T, because E not, they have given not, they have not given the E, so I need to write E in terms of V. So I'll get E, which is equal to V naught cos of omega t divided by d. Yes. Now substitute here JD, which is equal to epsilon naught dou divided by dou t of V naught cos of omega t divided by d. Now V naught is a constant and d is a constant. Yes. Now on taking epsilon naught V naught divided by d out of the partial derivative, what is inside? So dou divided by dou t into cos of omega t. Yes. Now on omega naught into V naught divided by d, do the partial derivative. If you do the partial derivative of cos of omega t is minus into sine of omega t, and according to the chain rule, I need to differentiate this omega t again partially, so I'll get omega. Right. So on rearranging the terms, it is minus omega epsilon naught V naught divided by d and sine of omega t. Yes. And this is the uh, answer for displacement current density, right, where epsilon naught tells you the permittivity of the free space, and V naught is the initial voltage that is given to the circuit, and sine of omega t, and d, omega is the angular frequency. Okay. So let us go back to the question. So what does the question we have? On oscillating voltage V of t, they have given across a parallel plate capacitor having plate separation d, the displacement current density. So the displacement current density we got minus epsilon naught omega V naught sine of omega t divided by c, so divided by d. Sorry, the right option is here, option 1. I hope the last question was very easy. What was the question? So we need to convert electric field. They have given the voltage, so electric field, which is equal to voltage V divided by d. After that, we substituted in the formula, we got the final answer.